Today with us, okay, the recording has started. Today with us, we have Eric Dahlberg. He will be the main presenter, founder, and president of Wine Secrets. He's been around for 20 years and targeted filtration with wine. And now that technology has just helped us understand how to recover winery processed water. So we're really excited to bring this technology now into the wastewater side with all the ongoing wastewater issues. Carl DeMano is our technical director. He's also been part of Wine Secrets for 20 years. He holds a degree in chemical engineering, and he has a master's of enology from UC Davis. He will be the main contact. So if you have questions after this webinar, Carl's your guy. Gina Giaconi is part of Summit Engineering. We are so happy to have her today. She is the principal and division manager of the wastewater at Summit. She has over 19 years experience in the water wastewater industry, and majority of that experience being in the wine industry, in water, wastewater treatment, disposal, reuse, design, permitting, all of that. So Summit is also the leading provider of design and regulatory interfacing. So she will be telling us all the updates today on the wastewater regulation. So take it away. Oh, I got to go over what we're covering today. So engineers really like acronyms, so we want to make sure everybody understands all the terms. So Carl will be going over like a glossary of words really quick. And then many have asked, why do we want to recover our wastewater? We'll cover that as well and update any regulations around wastewater disposal. What's the plan to get this all built and set up? We'll go over that, and then zero liquid discharge, any outstanding issues that we don't think those topics cover. And then at the very end, we will go over your questions. And now Eric will go over Wine Secrets and Veolia.
Hey, we're thrilled to have you all here today. One little wine secret that you'd have had to have been around for a while to know about. Wine Secrets actually got its start with a technology called STARS, which saved a lot of energy. 20 years ago, it was new and green. California Energy Commission gave us a contract to demonstrate this technology to the industry. And by gosh, there's a lot of the bigger players that use this now. It's a filtration technology that replaced bulk refrigeration. So GE Water, yeah, the same GE that you see on your light bulb, had an operation that made a lot of water technologies because it takes an awful lot of clean water to generate power, which is one of their core competencies. But they wanted a industry-specific rep for some of their products, especially ones that required specific technical knowledge. They got a big factory in Minnesota. They make a lot of membranes. They make a lot of systems. They make big ones. They make little ones. And one of the things that we learned how to do was take technologies that General Electric had developed to filter water, and we'd modify them, convert them, and optimize them to create results with wine filtration. That got their attention, and they asked us to join the team, so to speak. Our water adventure began when I was hanging out with some of their reps, and they showed me a new membrane that they were introducing. It was a small membrane that went inside of a digester to make it into a membrane bioreactor. And I took one look, picture this thing, and I knew exactly whose digester needed one of those. So away we went. We're not necessarily new to the discussions about recycling water either. We were talking to people back in 2015, 2016. That there was more than a little bit of interest, and then it started to rain again. So, by the way, while I was riding in today, I heard on the radio that the drought's over in half the state, so some of you can go home if you want. Anyway, we're back. We have a lot better understanding. There's some new industry pressures that I think are going to make recycling a much more viable option, and we're a little bit better equipped to help out. We brought on a design specialist. We have a full-on PhD in chemical engineering who knows, he's forgotten more than most people ever know about these cool tangential filtration systems that we'll be talking about later today. I'll close out with another little wine secret. Recovered Water Solutions and Wine Secrets aren't our only brand. We have another one called Engineered Filtration Solutions, and that brand has been pulled into some other non-standard applications. We're actually constructing pilot systems for lithium extraction, which is another area of green tech. So anyway, Carl's now going to tell you a little bit about some of the glossary for water recovery.
Okay, thanks, Eric, and thanks to everyone who chose to attend. It's nice to see there's so much interest in reusing and recycling water within wineries and other facilities. I'm not going to bore you reading this list. The list is there for your use and for your reference. I just will point out a few high-level points. The general order is the reason a lot of you are here today, and we're going to learn more about that during this this presentation. And LDR, your land disposal, is essentially the big part of the general order. And then things you'll hear: BOD, TSS, TDS. That's everything there is to do with wastewater, organics in your water, suspended solids or dirt in your water, and then salt in your water. And a lot of the important points of the general order and your restrictions have to do with getting salt out of your water. Everything else is spelled out there, or we can provide more detail later. I will mention zero liquid discharge. Zero liquid discharge is when you're at about 99.5% of your water being put back into your facility. It's a lofty goal. It is mandatory in some countries and in some industries. So it's a little bit more than just a goal. It may become a reality for some producers sometime down the line. So I'm going to turn this back over to Eric to discuss why you'd want to do this, why we're doing it.
Thanks, Carl. One more time, we really appreciate your time, your presence, and your interest in saving water. So back in the day, it was pretty simple. You had a well, you had a pond. Back then, our greatest concern about rain was whether it was going to come during harvest or not. Water was ample and inexpensive. Waste pond management could be challenged, though. Sometimes you had to be careful about what went down the drain when. Conventional wisdom was that reclaiming water other than for irrigation just plain cost too much. Today's reality for wine producers includes drought, receding water table, regulatory costs on your influent, effluent, and other points within the water cycle, regulatory scrutiny on your well water usage, and even more. These factors in their combination offer the possibility of interrupting your business or checking your plan for growth. We've grouped these and other factors together and called them water risk. Regulatory constraints may require changes to how you manage your wastewater as well, not to mention the additional burden of monitoring, recording, and reporting your water activities. Our good friend Gina from Summit Engineering will be sharing detailed information about this oncoming requirement. We're there with you. Our wine filtration brand, Wine Secrets, also operates a wine processing facility in Sebastopol, California. Our facility made the transition from use of a permitted spray field to a hold and haul system. We'll tell you a little bit more about aspects of that transition later. Ponds and spray fields take up valuable real estate, especially here in the North Coast. Replacing ponds and land application areas would open up some more space. Could anyone out there use a few more flat acres? There are positive opportunities as well. Who's familiar with the term ESG? Today's stakeholders are increasingly interested in sustainability metrics beyond financial performance. Also, is there an opportunity to take the least sexy aspect of your operation, the waste lagoon, and in retiring it, create the kind of green story that younger consumers seek? Time's right to consider reducing your water use footprint through water recovery technologies. We refer to reducing your current water consumption and ensuring you can do more with less water in the future as water security. It's something we can help you with. Now, Gene is going to add some important detail to your regulatory outlook.
Found the mute button. Good morning, everybody. Thank you, Eric and Carl. So aside from facilities just having their own sustainability goals for water reuse or water recovery, there are new regulatory requirements that you may have heard of. The Winery General Order was created and adopted by the State Water Resources Control Board to be an overarching regulation for the discharge of winery wastewater to land. And the reason that this order was formed was because there were individual orders for facilities and it became very a mundane permitting process. And so they wanted to create alignment amongst the state and have a standardized set of regulations for facilities to comply with. That has some good and bad, trade-offs, but it is what it is. And the order was adopted this past January. So the overall intent of this order is to prevent the degradation of groundwater and to protect groundwater from the organics, salts, and nitrogen from getting into the groundwater sources and degrading it. So this is enforced or implemented via proper treatment and making sure you're disposing of it in a sustainable way. So the way that the general order is set up is, or regulated or implemented for each facility, is you will have a set of regulations based on your tier level. And the tier level equates, or the way that your tier level is classified is based on the volume of wastewater that your facility produces annually. Most facilities look at, the annual wine production or case production of wine, and you either have flow measurement in-house, so you're tracking your wastewater generation associated with a wine production level, or we would create and come up with assumptions for what your wastewater generation is if you are not monitoring it. But regardless, that tier classification is based on a calculated or measured wastewater flow that is generated from the facility. One important thing on this slide is that there is an exemption category or tier level. If you are producing less than 10,000 gallons of wastewater, you do not need to comply with the general order. So as I mentioned, the general order was adopted in January of 2021, requiring facilities to enroll by January of 2024. And we're starting to see some facilities that have already enrolled just due to, they're a new facility or there are other building permit triggers that are requiring them to enroll. But if you have not heard from your local regional board or county, I've heard that the regional board is starting to send out letters, mostly to facilities that do not currently have an operating permit or a discharge permit. They're starting with those facilities and then they'll work their way up to facilities that have current permits but just need to transfer over to the state general order. Facilities in Napa, just recently, Napa County, some of you may be aware, Napa County has oversight for winery facilities within their county limits based on an MOU that they have with the San Francisco Regional Board. And Napa County have been trying to continue that MOU, Memorandum of Understanding, to retain oversight of winery facilities and discharge. But it's, bureaucracy and regulations take a while. So they're still working through that. And as such, Napa County facilities are allowed to apply for a 3-year extension for enrollment in the Winery General Order, as long as they have a current operating permit with the county and their system is in good condition. If you haven't seen that letter from the county, you should be receiving it soon. The county has been issuing it when they've come out to do inspections. We have a copy of the letter and would be happy to provide it to you. But that is one blessing for the Napa County area in order to just extend your enrollment timeline. Other facilities, like I said, you should start to see letters soon. And otherwise, the deadline for enrollment is January 2024. Once you're enrolled, you submit a technical report and application. The regional board comes back with a notice of applicability, and you have 5 years to make any improvements that are needed to comply with the requirements, such as pond liners, treatment upgrades. Any commingled subsurface systems will need to be either segregated or provided with pretreatment. So there are nuances, for each facility based on the type of treatment you have and the tier level that you're in, that will drive what sort of improvements are needed, as well as what operational and maintenance requirements there will be, such as groundwater monitoring. Only Tier 4 facilities will have to provide groundwater monitoring and will have to have sufficient groundwater wells in their land discharge areas. Tier 3 facilities, just depending on the water quality, may need to have groundwater monitoring. And that's the general order in a nutshell in three slides.
Hey, thank you so much, Gina. The community is really, really lucky that you and your team over there at Summit have your eye on this particular flying brick. How does this general order connect with water recovery systems? Most of you are already complying with earlier regulations to control the levels of organics and suspended solids released into the environment. Ponds, digesters, and even worm farms can help you with this. The general order is about salt. To remove salt, you need specialized filtration. Filtering water into low salt and high salt fractions is the way to go. Reverse osmosis filters that can keep salt ions from passing hold back any biocontaminants or organic toxins, because these items are even larger than salt ions. So your low salt filtered water is probably cleaner than what's coming out of your groundwater well or your municipal feed. Rather not do this? Water Board Order WQ 2021002-DWQ, as released, has an opt-out for wineries that hold and haul their wastewater. No water on the ground, no need to monitor for salts. Our calculations indicate that systems like those we're developing could filter the salts from a 200,000 gallon per day winery into a single semi-tank of wastewater concentrate per day. Now, my associate Carl will share aspects of a 3-step plan to help guide you towards water recovery.
Okay, great. Thank you, Eric. So if you're interested in learning more or starting down the path to water security, we have a 3-step process, as was mentioned. The first step is a water risk assessment. We're going to get to know you and your wastewater system a lot better. We're going to issue a questionnaire, ask you some basic questions like how much wastewater do you make on average, peak, at your low point. And if you've got analysis, we'll want to see that. If you don't have analysis, we will grab a sample as we walk through the facility, which is also going to be part of step 1. We will not only identify some opportunities for direct reuse or low investment reuse, but we're going to understand the challenges in your winery to implementing some of these solutions. We will go ahead and issue you some recommendations both on direct reuse and recycle options, what we believe are the best group of process steps to get you the best benefit we can. And then if we need to prove it to you, or you'd like to see it proven, we can set up a trial, take some of your wastewater, treat it, and show you what the end result will look like. That'll bring us to step 2, where we're just digging in a little deeper. We're going to give you detailed reports as to the capital outlay for this project, how much it's going to cost on a regular basis. We'll be able to start working with your engineers or your contractors to understand what's necessary to write the proper permits to do this. And we'll also, at this point, discuss your goals, which is probably the most important part. You may want to just reduce some of your water consumption. You may want to go to full recycle. You may be ahead of the curve and want to do zero liquid discharge. We're willing to work with you however you want to decide this. At this point, we'll also go out in the world and see if there's interest in funding some of these projects. There's a lot of available money in grants under the infrastructure program. And we may be able to find someone to help you pay for implementing these projects. That'll bring us to step 3, which would be to implement. I'm sorry, go back. Okay, I missed this part, but I have mentioned reuse in a couple of occasions, so we will touch upon it here. If you're a small producer, if you're strictly hold and haul, or you're just interested in optimizing your reuse before you start implementing recycle programs, we can help you with that. As I said, we're going to identify some quick and easy ways to reduce your water. There are also small appliances, small machines that can quickly clean your water at the point of generation, so that you can directly put it right back into whatever process you're using. The benefit of this is that there's no permitting. This is just part of your winemaking and tank cleaning or equipment cleaning process, and just exists within your winery. And then, of course, we'll help you start those systems up, providing training, and then maintenance and reusables or replenishable items on the back end. So with that, we'll go to step 3, which is your permitting support. We'll go ahead and skip to the next slide. Seeing as we're out of room now that we've got all 3 parts of the process here. So we're going to start ordering your equipment and then working very closely with your engineers or your contractors at this point. Once it's in the ground and piped up, we will help you start this system up. And then again, whatever supplies you need, repairs, maintenance, ongoing training, we are there to help you as well. So when we talk about the recycling system, there are any number of options that we can implement. We're going to demonstrate 2 of those here. In general, from what we've seen, most wineries will have the first 3 steps, some sort of screening, pH adjustment, and a digester to reduce BOD. You may or may not have an ultrafilter and MBR. This is critical to implementing the steps downstream. We've got to reduce the dirt, essentially, total suspended solids, in order to run these downstream systems. The first to your left is an EDR train, where we're going to use electrodialysis reversal, which is a very robust electrodialysis system, which is a membrane and a electrolysis, which is going to draw specific ions through the membrane depending on their charge. Very similar to the equipment we had when we started this company to do tartrate removal. That'll give you about 80% of your water you can reuse as, say, cooling water, tower water, or wash water. But as we mentioned, the trick to reducing these is salt. So the 20% that leaves the EDR has a higher concentration of salt. So then we look to RO, or even our osmotically assisted RO, which is a way to really press the water out of this concentrate stream. And at that point, you're either at 94% if you've implemented the RO, or just a little bit higher if you've implemented the OSRO. As Eric mentioned earlier, if you're a 200,000 gallon per day wastewater discharger, this now squeezes down to the point where you can haul this off site, and you are now out of the land application business. If you'd like to go to, as we called it, zero liquid discharge, then you would implement something like a crystallizer, which is going to recover that last almost 2% of the water, probably like 1.5, 1.8% of that, leave you with a pile of dust or maybe wet solids that can potentially be recycled at a salt production plant or hauled off to landfill or something along those lines. The other side of this implements a nanofilter. This concept came about as a softener, but as a way to provide a water that is can be optimized for vineyard irrigation or crop irrigation. What will happen is the discharge of this, the outfall of the nanofilter, will have calcium and magnesium and other similar molecules that are beneficial for plant growth. So you can now optimize your water fertigation irrigation system where you're actually getting beneficial nutrients in the water. The rest of the water is then recovered with an RO, or again with the osmotically assisted RO. Again, squeezing that down to the point where you can haul that off site. You may choose to do a partial. You may choose to condense this water down, part of it put back to your land application. Again, the restriction in a land application are pounds of salt and not gallons of water. But if you can move half your salt or 3/4 of your salt off site, either in a truck or in a pile of dust, then you freed up the land for that application area and reduce the amount of water coming out of your well, allowing you to cut back on water usage or debottleneck and increase the size of your facility. So we call this extra for experts. Nothing comes without a cost, I suppose. So as you can see along the bottom, the greater percentage of water that you recover, the higher the intensity of the process. And what this means is you may get to a relatively high water reuse in that 94%, something like that with an RO. But as you start to move to the osmotically assisted RO, as you start to move to crystallizers, there are other steps involved in there. We will end up having to put in several other unit operations to support those machines with the escalating cost that goes with adding more hardware. So, as desirable as a zero liquid discharge system will be, there are costs associated with it, and we'll work with you to understand those and provide the system that meets your needs as best we can.
All right, thanks a lot, Carl. The thing to do is get the zero liquid discharge system so it's really cool, and then you can put it right next to your concrete egg. So, hey, before I get into this slide, had me a little stage fright when we first turned the camera on, and I forgot to share something really important, which is the fact that GE Water, who we started out with, was acquired and then reacquired. So you guys know, some of you working with the bigger wineries know exactly how that works. But what that means to you is we are now the wine industry's dedicated pointy end of a $30 billion water specialty engineering company. All right, so now I'm going to tell you about a little success story, and then Gene is going to tell you about a big success story when it comes to recovering water. So at our facility, we're relatively small. We do, at the time we were doing 3,000 to 5,000 gallons per day. But when we left the spray field, we had to stop using that because we were having issues with soil saturation during some rainy years, and we were having some smell issues during some other seasons. So it became prudent to abandon that method of water disposal. So when we first started a hold and haul program, our costs were $5,000 to $7,000 per month. We were being charged by the truckload for disposal. So we turned around and challenged the operations team to find ways to reduce wastewater volume and thus cost. Once they started doing this, they identified two maintenance issues with our well water treatment system that were creating overflows. This was often happening during nights and weekends when nobody was around. We weren't really aware of it. So once those problems were identified and corrected, our volumes for disposal decreased. Sometimes you go out looking for silver and you find some gold. The team then realized that we could save water generated by the CIP for our large wine reverse osmosis unit. They set up a two-stage filtration system, and that enabled us to reuse over half the water required for each wash cycle. Those of you that are running cross-flow filters, the wash water coming from it is really similar to what we're getting off our filter, and the water reuse solution we devised might just work for you. So thanks to these changes, our cost for water haul off has been reduced down to $2,000 to $3,000 per month. And we're not part of the general order because we're moving our waste off site. So Gina can now tell you about a big success on a strategic level when you begin with the end in mind.
So for this case study, we worked with Silver Oak on one of their ground up facilities out in Alexander Valley. This was a groundwater scarce area, and so they were very conscious about reusing water to the greatest extent possible. And so with them, we developed the design for what ultimately ended up being an MBR system. We went through the due diligence of selecting the proper treatment process for them, and ended up deciding to go with an MBR. And that system was designed for almost 10,000 gallons per day of processed wastewater treatment. And the effluent quality was of high enough quality that they could use that water for barrel cleaning, tank washing, floor cleaning, and toilet flushing. So as part of the design, because it was, again, ground up, we were able to design a dual plumbing system so that they had segregated plumbing for potable water and then recycled water. And if for existing facilities, that sometimes isn't as feasible, but when you're designing new infrastructure, dual plumbing was the way to go for them. And so, as you can see, the water is clear. They have had periodic issues with tannins and color in the water. It's an aesthetic issue. It's not a quality issue, but there are processes that can be added to the treatment train to address color in the water.
All right, thanks a lot, Gina. Even though we've got a pretty good handle on the technical method to make water recovery happen, there's still some related issues that need some work. Water recovery is new thinking, and these issues are really important aspects of taking this process mainstream into our industry. The first issue is really important. Gina mentioned building from the ground up and being able to put in multiple parallel utility systems. But the simplest way to use recycled water without creating the separate utility systems is going to be to reintroduce recycled water into your existing water system forward of your current process treatment plant. This is going to require some clarity for the regulatory community on the use of treated water for food-facing uses. A couple of facts, though. It's already being done in the beverage industry here in California. Another fact is that California's current rule book on wastewater, Title 22, does not apply to winery wastewater unless your sanitary waste system and your process waste system are not separated. In California, we would only expect commingled wastewater in small wineries using underground septic systems. Finally, recycling municipal wastewater for full reuse is becoming a reality, not a choice in parts of Southern California. So we're going to be working on a campaign to develop a body of proof and precedent, which should be enough to bring the regulatory and other stakeholders on board as we get towards a point where permit approvals are going to be required. We're investigating both developmental and end user funding for these types of projects, as Carl mentioned before. This will offset both our costs and your costs and reduce the barriers to moving forward with water recovery. Also, The residue from water treatment will be a concentrated solution of sodium, potassium, chlorides, sulfates, and a few other ions. The current method of disposing of this liquid is transportation to a large municipal treatment plant, such as those operated by East Bay Mud. However, the use of this option may change over time. We're looking for industrial producers who are interested in the salts. As this waste is from beverage production, there should be few barriers to putting it in front of a plant producing industrial salt. Researching and finalizing this step of the recovery process would be an ideal use of stakeholder funding. Good news, we have a bit of time before the state requires full implementation of recovery solutions, and we're confident we'll have the answers to these issues by that time. So we've given you a lot to go on this morning. I'm going to turn the microphone back to Sharon, who's going to open up the floor for questions.
So we have a couple questions right now in the Q&A section. If you have any questions that came up during our presentation, questions on the technology, question on the process, please put that in the Q&A and we'll address them right now. So this will be a great time. We have a question from JJ. Where do you haul the brine to? Who accepts that? Gina, you might know a couple vendors.
I know that, East Bay Mud has taken the brine historically. I know on the Sonoma County side, they've been trying to find a place to haul to the city. I don't know, Eric, if you've had any success with that. I know some people have.
Yeah, ours is going right down the road to the county plant.
Yeah.
But again, right now it's more about the organics than the salts. And
yeah, the brine stuff, just to extend on that with the winery general order specifically, you will no longer be able to send softener discharge direct to wastewater disposal. You will have to find another means for treatment or hold and haul that brine. Those are basically the two options. And then in addition to that, the FDS requirements are such that you cannot add more than 320 milligrams per liter of FDS to your source water. And so there are definitely going to be either source control or treatment requirements to get those FDS levels within spec.
And then Travis just typed in, is it Lana Transfer Station in Sonoma County? Anybody know how to pronounce that?
Yano.
Yano. Yano. It's spelled very differently. And then Clark has a question. Say you have 5-acre wastewater pond in Napa Valley, on the Napa Valley floor, which has been operating for decades. Now you replace the pond with your technology. What challenges will a viticulturalist face converting this land to a Cabernet Sauvignon vineyard? Eric or Carl?
I can start, but then Gina could probably tell us something also. It's going to depend on how much got through, how much material got through your liner. In general, in Napa County, we're seeing that between the quality of the well water and a little bit more ample precipitation, the salt loading is not quite as high as maybe if the 5-acre pond in question was out near Merced. So, you'd have to do a little bit of analysis underneath, take a look at your metals levels. More than likely, you're going to be backfilling and blowing in a layer of overburden anyway. Carl, you'd know how deep Cabernet roots go. And again, where we're going here is this would be a bit of an engineering project, and there may not necessarily be one answer. On the other hand, let's say that you couldn't, 5 acres would be a great place to put another parking lot, an event center, or any number of things that, would make you more money than your pond on flat ground in Napa.
No, I think that's right. And I think what would happen is you would look at your land application area first, right? Once you can start reducing the number of acres you need to spray water on the ground to dispose of it, then you can start reclaiming that. We've seen customers who that was their goal, is to just stop spraying water on the ground and reclaim it as vineyard. So, you know, start there. And then, yeah, as Eric said, it's probably an engineering program. That's more than likely a lot of new dirt to start a vineyard, but you can always use land, whether it be for tank farms, parking, event space. Yeah, but I would look at the land application area first to reclaim as vineyard.
And I would echo everything that Eric and Carl have said. You know, if you have a pond, even though it's old, if it does have a sufficient liner that has protected the infiltration of wastewater into, you know, the subsurface soils and whatnot, then you might not need as much. You might not be as concerned with the metal levels or the soil composition as you would for a more infiltrative type of situation. But otherwise, it is generally just a grading exercise, and you need to look at the soil type to determine, you know, where the soils can go, and if you need to over-exc and bring in additional new soil.
As an extra point, there is a facility up valley in Napa, which I won't name names, but their waste pond is just a little bit south of their tasting room. I'd love nothing more than to close that up for them, and you know, they could put anything there.
We have had a number of facilities that have.
Next question from Jason. Which process will best? Oh. Did Gina get frozen?
You're a little frozen, Sharon. Is it cold down there in SoCal?
Yeah, I didn't hear
it's
that.
Funny today. Okay, this is from Jason. Which process will best reduce nitrates? Carl, maybe you could take that.
If not, Gina and I know that's best handled as part of the digestion phase.
Next question is from Eric. Can you please describe the crystallizer technology and what type of footprint will be required? Does that eliminate the need for hauling liquid brine? Carl?
Again, you're using heat and other mechanical means to remove the water from the solids. Run well, the crystallizer is going to, we call it 100% water removal. You probably end up with a kind of a powdery substance where you can't get all the water out of it, so call it 99.5. No, you don't have to haul that off in a tank truck. That's probably a dump truck or a small truck like that, to hopefully take it to, you know, a salt recycler like Eric mentioned earlier.
Great. The next one is from Elena. What is the cost associated with the 3-step process to create a plan other than equipment purchase, if you get to that point? Carl?
So there'd be a small charge for step 1 for us to come in, examine your facility, and make some recommendations going forward. If you may stop there, and that is fine, or you may want to table it and come back to us. To go to step 2, we will write a proposal for that. It's essentially going to be an engineering study, so it'll be on a time and material basis for us. So we'll have an hourly rate. We'll give you some ideas to how long it's going to take us to design the facility that you need and present it to you. That'll give you the cost, both the capital cost and the yearly operating cost to operate that facility, along with some estimate as to the total install cost. And then obviously step 3, you've agreed to the total install, you have that number in hand. Again, it's going to be a function of your goals how far you want to take the recycling and the your wastewater, not only flow rate, but quality.
This one is specifically addressed to Eric. Will your filtration technology allow commingled treated water to be used in other areas of the winery other than the original permitted irrigation fields?
That's certainly the intention. At this point, the water rate Sacramento's had 2 attempts to promulgate standards for the use of recovered water for food-facing uses. They hadn't quite made it on, over the fence for the first 2 times, but there are some other agencies out there that, without guidance, have come up with some pretty solid guidelines. There's also what I would call tactical use. For example, a lot of us have chillers; those are very thirsty, and literally peeling off some water, cleaning it up, and sending it up your chiller stack is a really good way to go ahead and reduce both your use and your discharge.
This one was submitted previous to the webinar. Are there any methods for water reduction and cellar sanitation of tanks, floors, barrels? Maybe Eric?
Like everything else, it really kind of depends on the kind of volumes you're generating. There's certainly technology that can recover barrel wash water. There's already modules available for some of the larger beard systems that are out there. Sinks and things like that, you're starting to get a little bit small. You can filter almost anything and everything. The question becomes the cost effectiveness of doing so. In general, we'll be looking for what I would call low-hanging fruit. Tank wash, if it can be collected efficiently, barrel wash, filter wash and things like that, and possibly tactical recovery for chillers and other unit ops that would be in the winery. But for the smaller uses, it's going to be way more cost effective to round them up down at the bottom of the system where your treatment is and do your recycling down there.
Okay, if anybody feels like their question's not answered, we have put Carl's email here. Feel free to email him. It's carl@recwatersolutions.com. So everybody, feel free to reach out to Carl. He would love to answer any of your questions. Thank you all for coming. We really appreciate you taking the time out today. Follow us on LinkedIn. We're going to actually be posting the latest on the water recovery technology, updates on California General Order, and any like drought related news. That all of that will go on our LinkedIn Recovered Water Solutions page. So follow us there. And thank you all for coming. We really appreciate you taking out the time, and have a wonderful day.
All right, thanks for coming. And again, Gina, thank you for joining us.